Why is the night sky black? Does dark matter really exist? And do we need a cosmic expansion to explain the redshift our astronomers observe on distant objects? These questions we will answer today under the light of Burkhard Heim's theories. Hello and welcome to 6 Dimensions in Color. My name is Schmid. On this channel I explain to you Burkhard Heim's worldview in understandable language and with clear examples. Perhaps there was a moment in your childhood when you looked up at the heavens in amazement and your father, mother or grandfather explained to you all these little lights up there are distant suns just like ours around maybe which other planets revolve. Did you know that this very fact was even known to a Catholic monk called Giordano Bruno in the 16th century, long before there were telescopes and other instruments to observe these distant objects? Giordano Bruno got these insights through an inner dialogue with a superior source of knowledge. Just very much alike as you learn when you do NATHAL training. In NATHAL training, you tap into the very source of our knowledge, the energy field that permeates the universe and which contains everything. And from this contact, you can gain knowledge over any imaginable and unimaginable field, be this science, research and development, be this business strategy, or your own personal development, spiritual personal development, or philosophical insights. If you're curious, have a look on my website dubaiplus.com, book one of my trainings here in Dubai, or let's organize something anywhere else in the world. Anyway, back then, when I was a child, I was naturally very disappointed when I was told that these distant stars were unimaginably distant and there would never be a chance to reach them in our lifetime. Well, today I'm no more disappointed because I've explained at length how interdimensional travel really works. So it is theoretically possible. Nevertheless, a mystery remains in the darkness of the cosmos. Why is the night sky not illuminated bright as day by the billions over billions of stars in the visible universe? Well, conventional astronomy has two explanations for that. The first one: since a supposed Big Bang, the universe supposedly expands, and this causes a cosmic redshift. The more distant an object is, the more pronounced this redshift will be. So, and this redshift, of course, causes an attenuation of the wavelength and therefore of the energy of the individual photon. It's relatively easy to calculate how big the value of this expansion is supposed to be, and it turns out it's about 70 kilometers per second and per parsec in every direction. However, there are certain problems with this model. First of all, this expansion movement is not as smoothly distributed, as equally distributed in every direction as it should be according to theory. There are objects who seem to move much faster and others that seem to move much slower. So this Hubble constant is not so constant after all. There are numerous examples of these contradictions that were observed. A lot of them were collected by the astronomer Halton Arp, who even worked with Edwin Hubble for a while. Of course, there have been various attempts to kind of repair the expansion model of the universe, all of them introducing new assumptions, making the whole thing more complicated, and therefore none of it is very convincing. Burkhard Heim himself has always emphasized that Edwin Hubble himself never postulated, or never stood behind the postulate of redshift through cosmic expansion. He only said, quote, "It looks as if something is expanding," but he was never convinced that this would be the true explanation. It were others that have elevated the theory of cosmic expansion into dogma, and nowadays it become so institutionalized that it can hardly be criticized anymore. The second reason for the dark sky is the theory of the so-called dark matter. The problem with dark matter is, even more than 90 years after it was first postulated. No one still knows what it is. Not a single particle of dark matter has ever been observed, no matter how big the particle accelerator or how big the telescope was that was used. It's simply a placeholder for something we don't know. And there are all kinds of endless speculations of what this dark matter could be without ever questioning the assumption of its existence in the first place. Dark matter is only an assumption used to explain certain anomalies in astronomical observations, for example, the higher than expected rotational speed of galaxies. Enough of this introduction. This is not supposed to be a video about conventional astronomy. Burkhard Heim proposed a model of gravity itself, which has some rather unusual properties and which explains these anomalies and this behavior of the cosmos quite simply. However, I must give a disclaimer first, because this theory of gravity of Heim was never as substantiated as the rest of his theories. So he should have revised it sometime. Even friends and colleagues who meant well with him asked him to do so, but he never got around to it in his lifetime. So according to his own very high standards for the rest of his work, this would have needed some work over. In the video description, I'm linking an article of one Professor Konrad Grüner, in German though, but he delved deeper into Heim's theory of gravity and made some corrections and suggested some alterations. Anyway, I'm going to explain you Heim's original thoughts because they give you a very unconventional idea about into which direction we should think when considering a revision of cosmology. I have made a video before about Heim's approach to gravity and the inclusion of the field mass in its course. I'm linking that video up here. When Heim calculated this idea through, he came to an interesting conclusion, which is there is a limit to the attraction, to the attractive distance of gravity. The gravitational field starts at a lower limit and runs a certain course until it reaches a limiting distance he called ρ, which lies at a distance of about 15 million light years or 46 megaparsec. This is a distance versus probability analysis of galaxy distribution. So the x-axis carries the distance from a certain standpoint or from the standpoint of a certain galaxy, and the y-axis the probability that there is another galaxy at that specific distance. And you see, for closer distances than a certain boundary here, it's very likely that there is a neighbor, but beyond that, probability of existence of other galaxies is more or less random. And this distance, this border distance, this limit lies at about Heim's 46 megaparsec. So this is a very good support for his theory and his calculations. And it would explain the existence of clusters of galaxies, which are quite distinct structures in the universe, but beyond these clusters, there doesn't seem to be anything. There is this more or less random structure at large scale. Why might that be? Let's take a further look at our gravitational curve. So the gravitational force passes ρ and then becomes negative. That means at that distance, gravity is not an attractive force but a repulsive one. And as we move further away, we approach another limiting distance of the gravitational field, which is its upper boundary, called big R0. And this, at this point, at this pole, the repulsive force approaches infinity. It lies at a distance of about 15 billion light years, according to Heim's calculation again. And this, interestingly again, corresponds to the supposed diameter of the universe as we conclude from astronomical observations. But now we have to interpret this distance differently. What happens with light that comes in out of such a distance? Well, if gravity is repulsive, then kind of has to run up the slope. And that attenuates its energy, which gives a completely viable and alternative explanation for cosmic redshift. So a photon traveling a distance longer than, or a distance of r0, would virtually be extinguished. And you could not see beyond that distance, not with any means of observation. Heim spoke of gravitational light aging. And because this repulsive effect is emanating from distant stars towards any other point in space, cosmic redshift can also be observed for objects, for light that comes from a distance closer than 15 million light years. And it also explains why the redshift effect is different into different directions. It simply depends how many star clusters, what density lies behind that, and producing this repulsive effect. Even if the foundation of this theory is not as solid as the rest of Heim's work, it gives you a very interesting alternative idea about why the cosmos is behaving like it does. So maybe we should be bold and abolish this whole Big Bang cosmic expansion thing after all. As you may know, the concept of dark matter was first postulated by astronomer Fritz Zwicky. And Heim indeed did correspond with him. About his calculations, he sent him his calculations, and Zwicky replied to him, and I want to quote that, or rather quote Heim's statement to Zwicky's response to him. He said, "Thereupon I wrote to Zwicky. In his reply, he mourned and said that he was in fact aware of these anomalies. He could even prove it with photos, but he wasn't allowed to publish those pictures. He said the same about photos of star bridges. He could not publish those either and said, there are certain anomalies in the redshift that indicate that it can't be in expansion. But that contradicts some famous people's theories, and that would mean trouble." He said the pictures were lying in his desk drawer. And that's the shocking reality about institutionalized science today. It's no more the honest and pure quest for truth, but for reputation, power, and in the end, funding, of course. But let's get back to our gravity curve. The distance big R0 means the diameter of the observable universe, but no more the diameter of the universe itself. That's a whole different topic now. And in the previous video, I talked about the dimensions that Heim actually assigned the cosmos, the diameter of the total three-dimensional space, which are completely mind-blowing, in the sense of mind-blowingly mind-blowing. If you were to set off from Earth and travel to the most distant known object in space, Earth would then only be visible in the faintest radio spectrum when you look behind you. And if you then go on and pass distance R0, Earth would disappear in absolute darkness forever. But before you would not see the wooden fence with which the world is nailed shut. Those were Heim's original words. But you would see a new universe. And this would go on and on and on and on for very many times. If you think about the incredible scale the universe has according to Heim's theory, you can't help to wonder how many stars, galaxies, planets, and civilizations there might be. I think we need to define a new superlative here that even supersedes astronomical. I would say the number of civilizations in such a universe would be super astronomical. And most of them, or many of them, surpassing our state of evolution by far. One last note now for those who've been paying attention in the previous video, because I said the universe is after all expanding, that is increasing in size, because the number of metrons is growing. So that would qualify for a cosmic expansion and thereby for a cosmic redshift as well, or wouldn't it? But Heim did the math on that, and he concluded that the redshift effect of the expansion taking place in his universe would be many orders of magnitude below any threshold of measurability. So practically it doesn't play any role. These were Heim's bold thoughts on cosmology and the crisis of conventional cosmology, which has been prevailing for many, many years now. It could be resolved quite easily by a continuation of Heim's direction of thinking in 6 dimensions and in color.